In this video, we'll talk about what an acid and a base is, right? So an acid and a base can be defined based on two different definitions, right? So the first is a Bronsted acid base definition, right? And the second actually is a Lewis acid base definition. So according to a Lewis acid base definition, so we're looking at the second one first. So according to a Lewis acid base definition, an acid is a compound that actually accepts electrons, right? And a base is a compound that actually donates electrons. And notice that we are actually talking about electrons. We're not talking about H plus or OH minus. We're talking about electrons. So what would be an example of an acid, meaning a compound that will actually accept electron? So a compound or an atom or an element which would actually be electron deficient, right, would accept electrons. So an example of a Lewis acid then would be a species like H plus, because it does not have electrons. It's electron deficient, right? The plus sign clearly here means that it has donated the electron, or yes, and it's deficient right now. And let's take another example then. So BH3, right? And if you think about the Lewis structure of boron, boron does not have 8 electrons in its octet in BH3, which clearly means that BH3 is actually a Lewis acid because it doesn't have a complete octet, and it would do anything to accept the electron to complete its octet, right? So mostly species of borons would actually be Lewis acids, and then positively charged species would also be Lewis acids. So for example, CH3 positive is also a Lewis acid, right? And now an example of a species by itself, right, that would act as a Lewis base is, let's say, for example, a species which actually contains the electrons as lone pairs, and they would donate its electrons from those lone pairs. So for example, methanol, CH3OH, is actually a Lewis base, right? And then let's think about another one. CH3NH2, methylamine, again, is also a Lewis base because it has lone pair of electrons on the nitrogen. So species which actually contain lone pair of electrons on the atom are Lewis bases, right? And so now let's think about a Bronsted acid. So what is a Bronsted acid? So now the definition of an acid, according to Bronsted, is that a species which actually donates the H plus, right, donates H plus is called an acid. So a species which actually donates H plus. So what would be an example of that, right? So for example, HCl, right? HCl is a species that would donate the H plus, right? Because it can easily become H plus and Cl minus. H2SO4, it can very readily donate that H plus. And a Bronsted base now would be a species that would actually accept H plus, right? So an example of that species would be something like F minus, right? F minus would actually accept the H plus, and any species like, for example, OH minus would very readily accept the H plus, and that's why it would be called a Bronsted base, right? Now if we pay attention here, right? A Lewis acid is something that accepts electrons, and a Bronsted acid is something which donates the H plus. So although they're opposite in terms of accepting electron and donating the H plus, right? But don't forget, the terms are different. One is accepting electrons, and the other one is donating the H plus. All right, so have a great rest of your day now, and I will see you guys in the next video, and stay tuned.